In this video, we're going to talk about how to do unit conversions using dimensional analysis, and I'm going to show you 3 examples where I do this and talk through the steps each time. My hope is that by the end of the video, you're feeling comfortable looking at a problem, figuring out what you're converting, and actually doing that conversion. So let's start by converting 5.6 gallons to liters. So as with all conversions, in order to do a conversion, you have to have a relationship between the 2 units. You have to know how gallons and liters relate. In this case, there's 3.785 liters in every 1 gallon. So there's my relationship. When we go to do a dimensional analysis conversion problem, you're going to start with the value that you are converting, and you're going to begin by writing that down. And that's going to form kind of the anchor or the top left corner of our railroad tracks, which is basically a series of multiplication and divisions. And you can either leave the denominator underneath that 5.6 gallons blank, or you can put it over 1, because any number over 1 is itself. And then next to that starting question, you're going to put your relationship. And when you go to do your relationship, the unit you want is going to go on top, and the unit you have is going to go on the bottom. So in this case, I want liters. And so I'll put liters on top, and the unit I have is gallons. That goes in the denominator. And then from the relationship, I'm going to put those numbers. So there are 3.785 liters for every 1 gallon. So that leads us our relationship in the railroad tracks on the right, and the question that we're converting, the value we're converting, as our anchor in that top left. Once you have your train tracks filled in, then you're going to multiply the numbers in the numerator and divide by any numbers in the denominator, because these train tracks are really a series of fractions that are all being multiplied together. So you'll take 5.6, multiply it by 3.87, divide it by 1, and when you do that, you get 21.196. And when you go to do your final answer with these unit conversions, I want you to look at the original measurement and see how many significant figures there were. So in this case, there were 2 significant figures in 5.6. And so you're going to round your final answer to 2 significant figures. And so that's 21 liters. Okay, let's take a look at another example. So here we want to convert 5 kilometers into miles. Again, we need a relationship. 1 kilometer is 0.621 miles. Now that you have that, it's time to set up the dimensional analysis problem. So the unit or the measurement we're converting starts us off. So we've got 5 kilometers. And then I'm going to get my railroad tracks for the conversion. The unit we want goes on top. That is miles. The unit we have, which is kilometers, goes on the bottom. And into this second slot on our railroad tracks goes the values in the relationship. So I've got 0.621 miles and 1 kilometer. Then we math. So 5 kilometers times 0.621 miles divided by 1 kilometer. That is going to be 3.105 miles. Round. I had 2 digits that were significant in my original measurement. So I need 2 significant digits in my final answer. So this is 3.1 miles. So 5 kilometers is 3.1 miles. And if you were a runner, you probably already knew that. Okay, let's look at one more. So in this case, we have 78.69 years, and I want to figure out how many hours that is. That's the average lifespan for an adult in the United States. So how many hours do you have to live on average? For this one, as I look at it, I actually don't know how many hours are in a year. And so I could look it up, but instead, I'm just going to do this conversion in 2 steps. I know how many days are in a year, and I know how many hours are in a day. So I'm going to make a plan, and that plan is that I'm going to convert years to days, and then days to hours. And this will work for me because I know that 1 year is 365 days. And I know that 1 day is 24 hours. What we're going to be able to do is set up our conversion in 2 steps. Our railroad track is going to have 2 separate pieces to it. And so let's show us how this works. Okay, Again, as I start my conversion, the number I am converting will get me started. And then I'm going to set up my train tracks. And the unit I want, which is days, for my first conversion goes on top. And the unit I have, which is years, goes on the bottom. And there are 365 days for every 1 year. I can stop and get an answer right here. And this is 28,722 days. And then I can take that answer and convert that into hours. Which is 689,324 hours. Okay, so here, now that I've done both steps, now is when I'm going to round. If you round along the way, you tend to introduce rounding errors. And so I'm going to round to my 4 significant figures that were in my original measurement at this time. And so that makes this 6, 8, 9, 3, and then I still just need some placeholders, so I'll put a couple of zeros there. 689,300 hours. So when you do dimensional analysis conversions where it's a multi-step process, you can do each step independently, or you can string it together. And that would look like this. So if you opt for this method, you take your initial value that you're going to be converting, and then each step is its own numerator and denominator in the railroad track. So I did the 365 days per year, and you'll notice that years were top and bottom, so they canceled, because again, what you want goes on top and what you have goes on the bottom. That allows your units to cancel. And then instead of stopping to get an answer, I just kept going. My units I had now were days, and so I had days, I wanted hours. Hours would go on top, days would go on the bottom, so that those units would cancel out. You get to the same place. It is entirely up to you whether you wish to do it one step at a time or whether you want to string it all together. So hopefully at this point in time, you are feeling like you can convert numbers. So remember, in order to do a conversion, you have to know what you're starting with. You have to know the relationship between the units involved in that starting number and your target unit. And then you need to set it up in such a way, if you're using dimensional analysis, that the unit you want is on top in your train tracks and the unit you want is on the bottom, so that you will cancel out the units that you no longer wish to have and end up with the units that you want when you're done.